Welcome back. This is Mr. Takeda again, and I'm going to talk about probability today. And that's for certain. This is lesson 10.2 on probability, in which we ask the essential question, how can you describe the likelihood of an event? So we have this new word here, likelihood. In the previous lesson, we talked about the word event, so we know what that means. Let's take a look, shall we? Here we go, probability. Let's look at this definition together. The probability of an event is a number that measures the likelihood that the event will occur. Probabilities are between 0 and 1, including 0 and 1. This diagram relates likelihoods above the diagram and probabilities below the diagram. Okay, so if something is impossible, okay, probabilities are between 0 and 1. Something has a 0% chance of happening, then it is impossible. If it's certain it's going to happen, then it's a 1. So what are we looking at here? We're looking at percents. We're looking at its decimal. And we know what those are, right? Decimal and percents. We know how to convert those. And then we're looking in between. Okay. So let's look in the middle first. If something is 50% could happen either way, equally, it has to be equally, then that's going to be equally likely to happen or not happen. That's kind of a long thing that's going to happen there, right? So a good example of this would be flipping a coin. You have two possible outcomes. You have heads, you have tails. And because it's flipping up in the air and can land either way, it's equally likely to happen to land on heads or tails. Now, the ones that are kind of in between, unlikely and likely, and they're using these, they're using a 75% of it happening and a 25% of it not happening. So without getting into too many details here, let's say we had a spinner, and one of them was blue, and I could say, if I spin the spinner, what's the likelihood it's going to land on blue? Well, it's unlikely because there's only 1 out of 4 blue sections. But it's likely to land on the white because there's 3 out of 4 white sections. So they have these measurements here to go with these words, all right? And that's always kind of an iffy thing when you try to use words that are kind of vague to describe numbers, which are pretty precise. Let's take a look at our question, shall we? There is an 80% chance of thunderstorms tomorrow. Describe the likelihood of an event. What's the closest number we had here? We had a 0, we had a 0.25, we had a 0.50, we had a 0.75, and we had a 1. I'll put 1.00 to be fancy. Well, it was closest to this, right? 80% would be here, right? 0.80. So describe the likelihood of the event. What was our language here? That is likely. So this one, if it's 80%, it's likely going to have a thunderstorm tomorrow. Right? You're going to go to the one that's closest to. Try answering this question, and then we will put these, have a chance for you to put this into the pod at the end. There is a 20% chance of snow flurries tomorrow. Describe the likelihood of. Okay, so now we're going to find the probability of an event. This first part's important. When all the possible outcomes are equally likely. So when I was talking about flipping a coin, and we have heads and tails, each of those events happening is equally likely. That's why we flip it up in there and make it spin around. because we don't want to know where it's going to land, but it can land on each of those equally. So if they're equally likely, the probability of an event is the ratio, we know what that is, the ratio of the number of favorable outcomes over the number of possible outcomes. And it looks like this here, right? Oops. We use the big letter P, and then the event is what we're looking for. So the number of favorable outcomes divided by the number of possible outcomes. So this is a big idea for us. It's just a ratio. It's really more of like, it's a ratio, but it's just kind of a fraction, isn't it? Because the number of possible outcomes is the whole, and the favorable outcomes, well, that's part of it, right? Okay, so let's take a look at example 2. You roll the number cube. See, this number cube's not right because 1 and 6 should be on opposite sides. Oh well. You roll the number cube. What is the probability of rolling an odd number? Okay, well, on a number cube, how many odd numbers are there? What are the favorable outcomes? Well, we have 1, 3, and 5. So I have 3. This is the number of favorable outcomes. I have 3. And the number of possible outcomes, we know that possible outcomes would be 1, 2, 3, 4, 5, and 6. Right? So 6. Let me write these over here. These are the favorable. 1, that's 3. And the possible 1, 2, 3, 4, 5, and 6. So there's 6. And that reduces to 1/2. And then now we're going to put this in decimal form. We're going to put this in decimal form or percentage. So that's going to be 0.5 or 50%. You could leave it as 1/2 as well, but either of these, all these work. Okay. Try this one in example 2. So you have the same number cube there. What is the probability of rolling a number greater than 4? All right, when you get this. Okay, so now we've got using a probability. The probability that you randomly draw a short straw from a group of 40 straws is 3 out of 20. How many are short straws? So I don't know if you know this kind of not really a game. It's just a way that we can randomly choose somebody. Somebody takes a bunch of straws and they make some of them shorter than the others, and then they hide the short ends in their hand, so all the straws look the same length, and then people pick a straw, and then the people who take the short straw, they win, they lose. I don't know. We don't know what that part is for. We don't know what that is for. Only that this is a way to randomly choose somebody. Okay, because the person holding it, they have no control over it, right? They have no control over it. They're just holding them. Okay, so the probability is 3 out of 20. So we're going to use a proportion here. And so the actual, this is the probability, then the actual number of straws is 40. That's the whole. Again, like I said, it's really like a fraction. So the question is, then what's going to be our, I'll use X. Well, we can do this one by like equivalent fraction method, right? If 20 times 2 is 40, so then I can multiply the top by 2 as well. So 3 times 2, X is going to equal 6. So the answer here is how many are short straws? 6. So you can do a proportion. You could have done this cross. I could have done it cross multiplying style, right? 3 times 40 divided by 20. I could have done it that way as well. Okay. Take a look at this one. Answer this one. And that is going to be the end of the video. I'm going to try some more in class. We'll talk some more about this. Thanks a lot and have a great rest of your day. Bye-bye.